Hey, welcome back to Mini Rust in Rust. This is video 50, would you believe it? We are writing a little programming language, which so far we're trying to make it as much like Rust as possible. We're writing it in Rust. Eventually it will probably deviate, but for now, syntax and stuff like that, we just want it to feel just like Rust. So last time we managed to lex this definition. So we found these fun characters and we said, okay, that's the keyword fun, and so on and so on. So now let's see whether we can parse the same thing and turn it into a bit of an abstract syntax tree. Where do our tests live? Here we are. Okay, so I guess just at the end maybe. So can parse a function definition, I guess. That's not how you spell parse. And we won't get an array out of it. We're going to get something like some kind of syntax tree. Oh, does this return? This returns a vec of syntax tree. Yeah, because each function, like there could be lots of statements in here, but we've only got one, so it's going to be a list of syntax tree, but it's not going to be like a block like that. It's going to be something like function def, I guess. What shall I call that? Let's not abbreviate things. We could just call it fun, but oh, that's a keyword in Rust. That's going to make our life difficult. Let's call it function. I did abbreviate def here, didn't I? So it could be function definition. If I spelled it right, that would be even better. Function definition, why not? Okay, if that gets clunky, we'll see. Alright, so what do we think a function definition is going to consist of? It's going to consist of a name. So that will be something like, I think that might just be a type of leaf token, maybe? Oh, it's got annoyed with me because it doesn't know what a function definition is, so it's not auto-completing for me. Let's just have a look at what's inside a leaf token. Oh yeah, it's really unhappy. There we go. Okay, no, I just needed to save. All right, so what kinds of leaf token are there? Ints, floats, and symbols. Yeah, so I think that's what I'm going for. Is it's going to be a symbol, but actually. We even know the type of it, so maybe even passing in. Okay, so hold on. We need to look at the similar definitions where we define a variable, so a let block. A let statement must be one of those somewhere here, and because a let statement also has a thing in it which is a symbol, which is the name of the variable. So here we are. All right. So here, this AAA thing is exactly the same kind of thing as the name of a function. So it's an assignment statement, and then it has a symbol token as its first argument, and the type of that argument is symbol token. Okay, so I guess that's what we want, something like this, right? Okay, so here we go. Nope, that's definitely not where I meant to go. So the first argument to our function definition is going to be some kind of symbol token, starting from 1, 2, 3, 4. Going on for 4 characters. And right, so that was the name of the function. And then I think it's also going to have a body, which is a block, which is its body. And I guess at some point it's also going to have a return type and stuff like that. So let's just hard code that it returns unit. So I guess that will be something like this box. It will be a syntax tree, but boxed up so that it's allowed to be in there. So for now, basically, soon function definition is going to allow us to like actually parse out some kind of return type. There'll be like an arrow here. But for now, we're just hard coding that. We're going to just hard code when we actually write the code. This is just the test, obviously, but when we write the code, we're going to hard code that it's always returning unit, which is like bracket, bracket, nothing. And then there's also going to be a block here. And I'm pretty sure. Yeah, so here's an example of a block. So I think we're just going to want an empty vec. So it's going to be something like this to say there is a block with an empty vec of like statements. There's going to be statements inside the block of code. So basically this is the bit here. This is a block, I think, kinda. Oh, we'll have to think about that. Close the array, get rid of this stuff. Have we got the right brackets? No. How about now? No, got to finish off the function definition. That's more like it. Okay, so our block takes 2 arguments. The statements and the final expression. Alright, so I just deleted the code I needed for that. So the final expression of this block is actually just a unit because there's nothing in the block. So there's no pre statements before the final one, and the final one is just unit. Alright, so now it's saying, obviously, we don't have a associated function called function definition on syntax tree, so let's make one. It's going to work similar to these other things that we've got here. Let's put it at the end. So like this, and we said it took in the name, which is going to be a symbol token. Oh, and the argument, I was looking for what the argument's called, but I guess when you're doing an assignment, calling it symbol is not too bad because you're assigning a symbol. Here we just want to call it name, or maybe function name, one or the other. Return type is going to be a is it what did we pass in as our return type? A box of syntax tree. Am I absolutely sure that's right? I don't know. Oh, I'm putting these in completely the wrong place. Apologies if that confused you. Yeah. So it takes a name and a return type, and I guess we'll just call it block, which is going to be another box of self. I guess we're going to, like, if the wrong type of syntax tree is passed in, is this really right? Return type? No, I don't think it's right. When we do an assignment, yeah, this is what we're looking for, something like this. Oh, but that's just a symbol. Okay. We are not yet dealing with types properly. So that's not right. What we've done is not right. Let's not do the return type, because, in fact, I'll just put like a to-do in here. To-do return type. We haven't thought properly about types, it seems, which is bad, isn't it? So we won't pass that in yet. Still complaining. Syntax tree. What have we done wrong? What have we done wrong? I feel like something silly is wrong here. Can't compare syntax tree with bracket bracket. So what is bracket bracket? Like, is parse v returning bracket bracket? Is it just not saved? So confused. Oh, is it that function definition doesn't yet return the right thing? Oh, yeah, of course it is. Okay. Yeah, right. So it was returning unit. Okay, now it's complaining that we're not returning anything. Fine. So let's return something, which is just, so this function is just like a convenient constructor. So we're going to return a syntax node function definition, which is about to exist. And it's going to have a name and a block, which is going to be spelt right. And we're going to define this thing similar to these other things. And yeah, like the other places, we're not defining separate structs, although it says to do, maybe we should define a separate struct here. Okay, so just like that, name and block. I don't really want to call that block. What is that? It's like code or body. Is body. Okay. Let's rename this as well. It's the body of the function. That's better. Okay, now hopefully we're close to a failing test. What's not compiling? Should be in a box. Yeah, so every time we use a syntax tree inside a syntax tree, it needs to be wrapped in a box, because otherwise we'd have a recursive data type. So syntax tree would itself need to leave space for a syntax tree, which can't work. All right, so there's another error. Right, so we've added a new type. Hold on, let's think about this. So this is expression can be statement. So I don't think a function can be a statement. So I think we're going to add another thing here. Can a function definition be a statement? Oh, hold on. I think in this sense, maybe it can, because what the point is that when we get to the end of it, we don't need a semicolon. Okay, so I'm gonna change my mind, and we'll see if this works out, and say it can be a statement. And then if that's wrong, we'll find out. Alright, so other places where we deal with things, and we need to deal with this additional type of thing, function definitions. Alright, so we are in the evaluator, so we will just allow this to panic for now. If we try to evaluate a function definition, we'll get to that. Where else? Type checking, again, same thing. Just panic for now. It doesn't want to automatically fill in my code here. It's because it already exists. Oh, I just hadn't saved. All right. Okay. Another one. This is in the type checker again. Not sure why I've got the full expansion of this record here, but anyway, we'll do this. Where else? This again, what are we doing here? We're turning it into an error that's going to get displayed in an error message, so we won't actually write code for these to make these error messages look right until we have tests that that actually check that it works. Okay, so complaining that function definition is not used, it's fine. So we should have a failing test now. Yes, unable to parse this thing because we don't know what to do with a fun. Okay, so now we got to the point where we have a test for our parser and it's failing because our parser doesn't parse this thing. So we can start implementing. So when we find... So what we do is we find the first... So we're parsing something. We find the first expression and do some stuff. And here's where we check whether it can be a statement, whether we need to look for a semicolon or not, I guess. So expression, this function, is what's giving us back our thing, in this case, a function definition. So we have a big switch somewhere. Oh, okay, here we are. So this is it. If it starts with a let, then this is an assignment. If it starts with while, then it's a while loop. If it starts with an opening brace, it's a block. And I guess that's most of the things we currently cover. Okay. Oh, otherwise it's just like some kind of maths or variables doing some useful stuff. So we have conveniently, thanks to Rust syntax, got a convenient token that tells us that we're about to define a function. So it should be nice and easy. We're just going to, oh, hang on, let's not put it here. That doesn't work. This underscore is going to catch everything else. So it's got to come before that. And we're basically going to just call a function. Pass in the token we've already found. Actually, we don't even need the token we've already found. We're passing in other places. Oh no, maybe we need it for error messages and stuff. Alright, so a function definition is probably going to be something like... Hang on, there's no token kind function definition. Oh yeah, it's a keyword. It's a keyword. Yep, yeah, it should be token kind keyword. Keyword. Fun. That's how we lexed that fn set of characters. We said it was a keyword, and the keyword it is fun. And we're going to call a function called function definition. Now, I think function definition is going to be a bit like while, maybe. Maybe? Let's try. So let's make a function that's a bit like this. Call it function definition. And now this takes in end markers. And I'm not sure why. Because surely there's nothing that's going to end as kind of early after this function definition. So yeah, interesting. What does take in end markers and what doesn't? Or does everything? Because it needs to be kind of passed down. Yeah, alright, let's assume for a moment that we're going to have to pass in end markers here. Not sure. Alright, so the function definition is going to... so we found a fun. Now we're going to need to find a name. So let's have a look at what assignment does. So it finds either a symbol or a mute. So in our case, it's just going to be a symbol. So we basically need to find the next token, and it should be a symbol. Now I think we've got some quick way of saying, like, get me the next token of a particular type, as opposed to this check token of type. I feel like I know this token must be of this type. somewhere. Expect, was it something like expect token of type? Expect block is going to be useful to us in a second, isn't it? Let's keep that in mind. Yeah, token of type, I think it is. Yeah, get me a token and check its type. So that's what we want. That's what we want. So, where were we? Function definition. So we are going to do something like let name equals self dot token of type. We have to. I think that we provide the type here as maybe like this. I'm not sure. Well, what's name? What's the return value of token of type? It's whatever t. All right. So let's see where we use this because I want to make sure we do it right. So here, for example, it's a symbol. I think it comes out as a symbol token. Yeah, I think it comes out as a symbol token. So let's just say that. And what do we pass in? Oh, the previous tokens span thing. This is just for error handling. And we need to question mark it. So now we've got the name of the function as a simple token. So at the end, we're going to return. We're going to call our function definition function it was complaining we weren't using. We're going to pass in name. And we're going to pass in something called body. And body is going to be there, something like this. And we don't need this. Whoops. We don't need all this. Or this. A function basically is a name, an argument list, and a body. So the argument list is going to be... Let's just skip the argument. Let's just say skip the argument list. Because what we're parsing so far has no argument. And we do that by just expecting Is name got a span? Not sure. Yeah, so we need to bring something in of type like open bracket. Is it open bracket? What is symbol token? We need something a similar type of thing to symbol token. I'm not sure I can do token of type because token of type needs an actual type, and I'm not sure. Like the tokens that I care about have a whole type to refer to them. Basically, my generics are getting confusing. So check token of type takes in something which is of type try from token. So what things implement try from token? Symbol token, leaf token, and mutation token. Yeah, so I'm looking for a bracket. So what I want is to just say, get me the next token. And then I just assert that it's an open bracket. I think that's what's going to happen. Maybe some kind of type stuff would be good for this, but yeah. All right, so what is token type? Takes the previous token. And we better keep hold of this token because we're going to need to pass it into the next one. So open bracket. Right. Yes, we're not using end markers. Interestingly, expect block doesn't need end markers, which kind of means we don't need end markers. Maybe we'll get rid of this in a second. Anyway, so we need to just do some kind of... What is open bracket now? It's going to be a result, isn't it? So let's first of all return any error. It's a token, so let's just, for a second, let's do a match on open bracket. Basically, I've forgotten everything about my code. Whoa, what did I do? No. All right, no. So it's open bracket dot kind is what we want. And that has various types. And we want paren open. So I guess what we want to say is if... I mean, we could use the matches macro. How does the matches macro work? So if open bracket is not, what does that take? It takes in a thing and then a match. So we could say if open bracket dot kind doesn't match, token kind paren open, then fail in some way, which we'll deal with in a second. And then we'll do something similar for close bracket. We're going to need something cleverer than this soon, but like everything one step at a time. This matches macro. Replace if with match. What does that do? No, we don't want that. Doesn't know what matches is, that's what I'm saying. Oh, I just missed out the exclamation mark. Apologies. I'm sure you were screaming at the screen. So, close bracket needs to be a paren close, and we need to pass in open bracket here. I'll return some kind of error. Now we can get rid of all this rubbish. Fine. So, just to recap, we find the name of the function, then we expect an open bracket, then we expect a close bracket, then we expect the function body, and we return the whole business. So the kinds of errors that we want to print if we didn't find what we expected are going to be something like, well, there's missing expression. We want unexpected token. I think, oh look, there's a thing here called unexpected token. What does that do? It says this token was not expected. All right, but it doesn't say which token we did expect, does it? Which would be nice. So what types of error do we have? We have unexpected token, unexpected end of file, missing expression, internal parsing error, mutating non-symbol. So we want unexpected expression and unexpected token, and we want to say what we did expect. So maybe we just need a to-do here saying to-do, say what we did expect. And then we'll use this for now. So we can just call self.unexpected token, I think. And pass in open bracket dot span. Same kind of thing here. Like so. And we probably want to test to check that this actually is producing a reasonable error message. How are we doing for our positive test? Close. We just got the positions, the character positions wrong, I think. So can parse the function definition 3 to 7. Okay. All right, that test passes. Now we just want a quick test saying if the wrong thing is the function definition with the wrong stuff in looks wrong, then do something. A function definition without argument list is an error. So let's just miss out the argument list. That'll do, won't it? Now this is going to produce an error, so this is going to fail as we've done it. So instead we want to call parse instead of parse v. But we can't call parse on a string. We have to lex the input. So we lex this and collect it. Does that work? No, right. Once we've got it's not going to. Yep, right. So this is going to all happen here. Result. Parse the thing is going to be a result. It takes 2 arguments though. What's the other argument? The input. So let input equal this. And we're also going to pass it in here. Is that how that works? Yep. Get rid of this. So result is a parse. And then we're going to have to get tokens out of it. Surely we've got other tests that check parsing errors. Why am I wasting my time? Yeah, okay, so. Okay. Something like this. So we call next on it, and then we format the error, and it should be call next unwrap error. No, okay. Let's just copy this whole thing because this looks pretty weird. So I don't know why I thought it was a good idea to try and come on, give me my syntax highlighting back. Okay. To try and reconstruct this from scratch when we know it's difficult. Let's call this thing code. And then we can just pass in code here. It needs to be all unwraps. Make this map unwrap thing, you feel like there ought to be a function for that. Maybe there is. Alright, so now we format this and it should say, we even copied the right type of error because it should say unexpected token. And the code that it's complaining about should look like this. And I guess this token is the one it's going to be complaining about. Don't know why I pressed there. So probably that one. Is it going to look something like that maybe? I'm not sure how long this line is going to be or whatever. It's not going to be character number 1, it's going to be character number 1, 2, 3, 4, 5, 7, 8, 9. Maybe? Did I count that right? I don't know. So, close. Obviously the number's the wrong way round. It looks very close, except this should be line 1, column 9. That's good that failed, otherwise I would not have believed I'd done it right. Alright, so what have we done today? We have parsed a function definition by basically saying if you see fun, then start looking for a symbol, and then an open bracket, close bracket, and then a block. And then just to double check that our error handling does something vaguely sensible, we said if there wasn't an open bracket, close bracket, we should get ourselves an error saying we didn't get what we expected. Alright, so we're getting somewhere towards being able to write functions in our little language. Once we can write functions, just so much power is open to us, even if we don't have some of the conveniences like, say, for loops. We could always do things with recursion and stuff like that. So it starts to be a language that could almost do sensible stuff. Also, until we have function definitions, you can't write a Rust program because you need a main function. So that we've been kind of able to run programs, but actually we've been running little snippets of code that are not a full program. So I feel like function definitions, when we've got them, we're going to make this much more of a real thing and not a pretend thing. I hope you're enjoying the series. Do leave a comment, especially if you are. Follow on PeerTube, on infosec.exchange, video.infosec.exchange, or you can also follow me on Legacy YouTube platform. See you next time.